Hello everyone, I'm Tina Sun, and today I'm going to re-talk about did the Central Arctic become a sediment-starved basin in Quaternary? So here comes a question, because we all know that the Arctic ice is melting every year. So scientists really wanted to rebuild the ancient sea ice data in the Arctic Ocean. So now we can compare with the ancient one and nowadays to know what will happening in the future. So this is the course that is about to explore these things. It's called the Arctic Coring Expedition, which is ACEX, and it was done at 2004 summer at the Lomonosov Ridge. What's special about this is that it's the first ever and only science drilling mission in the Central Arctic. So before we jump into our research, there are a few things that you guys need to know first. First is about the MIS, which is Marine Isotope Stage. It was based on the oxygen 18 of forams. And when the MIS is odd, which is 135, such as these things, means interglacial period, which is hot. And by contrary, when MIS is even, it means that it's glacial period, which is very cold. The next thing we have to know is what is sedimentation rate? Different sedimentation rate would form different lengths of the sediment in the same period of time. So this means that we could now symbolize the resolution of the coral and the ancient sediment of environment. So nowadays, we could use the sediment trap, which is the picture shown here. We could use this to calculate the sedimentation rate. But what about the before? So scientists developed a lot of tools such as paleomagnetism and beryllium-10, also carbon-14 dating, such things, to recognize what's the ancient time sedimentation rate. Now we can finally look at our questions. So comparing with different dating methods in the multi-million years time scale, we could see that sedimentation rate is here, which is 15.8 millimeters per kilo years. But what about the very small part here, which is Quaternary? Before the 20th century, people used the paleomagnetism dating to build the MIS data, which is shown in the figure C here, this one. But later, scientists discovered a coccolithophore named E. Huxley, this one, at MIS 13 to 15, which is impossible. So they rebuilt the time scale like the picture D here, using these bio things. But nowadays, there are new hypotheses come out. At 2023, P. lacunosa, which is the other kind of coccolithophore, was found at MIS 7. But this one should have been extincted at MIS 12. So scientists started to thinking that maybe in a different part of the Arctic, the sedimentation rate is not all the same one. And also, in the center part, the sedimentation rate may be overestimated before. So here's our purpose. The first one is to determine whether the other tools like beryllium-10's decay profile and also the biostratigraphic data from ACEX are comparable with the paleomagnetic interpretations. The second one is that we wanted to outline how long-term changes in depositional rates should relate to sea ice persistence and also the position of the marginal ice zone. Here's our material and method. First, we use the paleomagnetism. This was done by the previous study. So at where there is hydrothermal, the hydrothermal would come out both sides. So we can record the direction of magnetism in the ancient time. So we compare the ACEX data with the other places. We could define the chorus dating. This is what scientists have done before. But nowadays, there are new things, which is beryllium-10 dating. So, beryllium-10 here is decayed from nitrogen and oxygen because of the cosmic rays from outer space. And when beryllium-10 was buried underground, it would, by time, decay into boron-10. So nowadays, we can detect beryllium-10 and 9's ratio to get the age of sediment. Here is our result. First, we compare the different ways, techniques, and interpretations. We see that the sedimentation rate in Quaternary by paleomagnetism is 1 to 3 meters per million years. But the sedimentation rate of beryllium-10 is 17.1 meters per million years, which is a very big difference. And by the way, the planktic forms suits the P. lacunosa, which is the coccolithophore before. So we could see that the bio way to detect the time scale may be correct. So to define whether Arctic Ocean is a sediment-starved basin or not, we have to define it first. So we could define sediment-starved basin as, first, the sedimentation rate is very small, which is mm or centimeters per kilo years. Second, there are very few tanagerous sediment supply. Like shown in the picture, they are all blue. And the third one is that it is usually very, very far away from the continents, like here. So a very classical sediment-starved location is in South Pacific Ocean. But let's look at the map of the Central Arctic. We could see that, first, the sedimentation rate translated by spatial. So we cannot define a average or something to say that Arctic is a sediment-starved basin, because you could see that at the margin it is definitely not. And also, there are many heterogeneous inputs, and it's very close, only 900 kilometers away from the continents. So we cannot say that Arctic is always been a sediment-starved basin. The next one is that, so what if the Arctic Ocean is not sediment-starved? Then why would we detect very small sedimentation rate? Well, Quaternary. Scientists discover that under the permeable ice, which is here, it means that permanent ice, there are very few sedimentation rate. But at the marginal ice zone and the seasonal ice cover, there are very large, which can up to 100 or even more millimeters per kilo years of sedimentation rate. So we could see that if it is more closer to the center, the core is more dense and short. But if it is more close to the continent, it will be very long and sedimentation rate will be high. And now let's talk about why paleomagnetism is incorrect before. Scientists give two ways to interpret it. First is that there is no evidence shows that all planetary transitions can be interpreted as chrome boundaries. And the second one is that the low organic carbon ability or high tide concentration will generate the reverse of chemical overprint. So this is why the previous study is probably incorrect. So here's my conclusion. First is that Central Arctic is not a typical sediment-starved basin. And the second is that classical paleomagnetism model is incorrect because it is incompatible with beryllium-10's decay and biostratigraphic data nowadays we renewed. So the third one is that the decline in Quaternary sedimentation may reflect the expansion of the sea ice. So here's my talk. Thanks for your listening.